So now we want to have another expression that is in polar corner systems. With the origin at the for this one, that one I want to show is, you see here the story, you just, right now you just listen, I give you a head up for why we want to do the second option. Here for hyperbolic orbit, we have two branches. And for either branch, if we have, say this is a focus here, and then once the celestial object is on one orbit, then it will go to infinity, or we will go around and go to the other directions. So one branch is real, one branch is imaginary for the practical celestial applications. Mathematics, we have two branches for sure, but for our practical application, we need to pick one. And if you use the wrong one, then basically you're going to mess up all the prediction things. So here, for the second option, I want to show you which branch you need to pick, okay, and with the corner systems. And actually, most of the textbook didn't describe this point. I spent a little bit of time and to dig it out, and then hopefully this one can share with you. So stay with me. So now we have a left branch. I'm going to do the two things simultaneously, and you can try it on your notes and put into two sections, and then parallel to do the writing. One page should be good enough. And left branch. For the left branch, this is the orbit. And this right branch. Then let me see the coordinate systems. Okay, so this is the center here, and which is not critical, and this is the directrix. So this is our focus. R, and okay. So with the polar coordinate systems, right now this is the origins. Okay, so that's the origin of the coordinate systems here. And if you wish, let me highlight the coordinate systems. Basically, this is our coordinate systems, and ER and E theta. Okay, so that's the coordinate systems here. So again, this is the angle theta, or true anomaly view. So from here, what is the distance? This is the distance to the equal to minus c plus d minus r sine theta. Again, I simply want to measure the distance from here to here. And basically that is these portions minus this portion. So that has that expression there, okay? So from R1 and R2, so using these properties equal to R1, R2. And so from here, R1 is the distance to the focus, and distance to directrix, this is R2 per our definitions. So this is R, and R2 is minus C plus D minus R cosine theta. Okay, so here we with the two forms, then we can have is minus EC plus ED minus ER cosine theta equal to R. So do the arrangement and a few steps. Let me ignore the steps, and R can be put into this P 1 plus E cosine theta. Okay. And for this one, we have do the similar things here. So this is the focus and our corner systems. The point. So this is theta. So this is our corner systems. ER, E theta. Okay. So the same thing here, we have the directrix, and this is the center. So the same measurement here, we have minus C, and we have minus D. So this is distance R. Okay. In a similar way, E equal to R1 over R2. And at this point, R equal to R, and R2 is from here to here. This is R2. Okay. Do this quickly. R2 can be described by R cosine theta minus C plus D. Again, if you look at the geometry carefully, and can you see it? Let me do this one. This amount is R cosine theta, right? And this amount, how much? Minus C plus D. Right? So therefore, from here to here, R2 equal to the two things, exclamation. Okay, with the things, and then again we have E R cosine theta minus EC plus ED equal to R. Okay, simply I use the two relations, have this one. Then again, a few steps later on, then we have is R equal to P 1 minus E cosine theta. Again, I don't want to box, but I want to show you. So here we have descriptions and we have a result. Which one will be useful? Here we have result 1. Here we have another result. Which one we're going to pick to make everything consistent? Do you remember the equation of the motions R equal to P 1 plus E cosine U? Right? That is the equation of the orbit. This is good for all kinds of the conic sections, for elliptic, for hyperbola, for parabola. So to make everything consistent, you see, we have to use this one, right? To use this one, basically, that is the coordinate system you need to pick. So which means, in your mind, in your definitions of the drawing, you need to pick is the left branch. Okay, so sometimes the information will be putting things upside down. So you need to put yourself, in that situation, you need to put yourself, if you put it upside down like this one, then say if you are a little person and understanding is in this way. Okay? And in that situation, actually this branch look to you seems is the right branch. But for that kind of situation, you need to still stick with this drawing. So the best way is you simply draw the left branch and then you simply put the rivers down and then you look at from the other side. And that one will give you the consistent things. Otherwise, if you pick the wrong branch, then I can tell you your calculation will be screwed up. Okay, so. And for hyperbola is nothing much. For hyperbola and that is pretty similar for, okay, let me do this one here. Parabola. For parabola, eccentricity equal to 1. Okay. And this one, again, we have two branches of parabola. Parabola is the one special case of parabola, the hyperbola. So basically, everything will be the same. So allow me not to repeat the same calculation, the same writing. But again, you can visualize this is the extreme case when E is approaching the converge to 1. So everything will be the same. Again, the same story. You can write it up in your notes is this. Picking up the right branch polar coordinate systems for describing parabola. That's it. And again, when we do the writing, everything will be the same. So I will skip off this one. So for this one, then here you can see R for the using the left branch. Okay, R will be equal to P, 1 plus E cosine theta, and particular E is constant. So basically here you can equal to 1, E is cosine theta. Okay, so again here we utilize equal to 1. So basically here is very special, the case of that one. For most of our applications, unless you do remember, probably you can stop.